Hello. This standard is Unit 3, Standard 5, and this time we're learning about higher order derivatives and applying it to position, velocity, and acceleration. And since all of you have taken AP Calculus AB, this should be, again, still review, and you should have seen a lot of it last year. The first part, higher order derivatives, is very simple. Higher order derivatives means being able, the standard, you should be able to take second, third, and more derivatives of a function. Okay, so the second derivative of a function is the derivative of the first derivative. Okay, sounds very simple. You should know how they write it. Second derivative, they call it f double prime x, or in change notation, they call it d squared y over dx squared. Third derivative would be f 3 prime, and then rate of change notation is d to the third power over dx cubed. Or if you see the pattern, it goes fn prime or dny over dxn. There's two different notations to mean the exact same thing. So I'm just going to go over one example because I think you guys understand this very well, but what if they say find the second derivative of a function? Okay, so if I take, for example, this problem, I will take the first derivative. In my notation, I'll call this y prime, which is 15x squared plus cosine x minus 1. And this one, 3 over x, means the exact same thing as 3x to the negative 1. Okay, so that means the exact same thing as, or the derivative means negative 3x to the negative 2. Okay, that's the first derivative. But the question asks for the second derivative, so I'm going to call this now as y double prime, and I will take the derivative again. 30x, derivative of cosine is minus sine, derivative of 1 is nothing, and derivative of negative 3x to negative 2, this now will become a plus 6, and this becomes x to the negative 3. And that is how you find higher order derivatives. It's not very difficult. It's all a skill you already know. It's just more opportunity for you to make a mistake. So make sure you check your work. Okay. Just because I think you already know how to do this stuff, I'm going to skip over the rest of these notes. Okay. The reason why we care about higher order derivatives is because this is a direct relationship to physics. Okay. Physics, they study something called position, velocity, and acceleration in kinematics. If you have a function for the position, like whether you're walking, you're launching a rocket, if I can make the position a function, I can take the derivative of that and find its velocity at any time. Okay? Or in other words, if I know where something is at a certain time, I can tell you how fast it's going. By the same token, if I take the derivative of the velocity, I can tell you how fast the acceleration is at any given point. So velocity is the rate of change of position. Okay? Acceleration is the rate of change of velocity. One special thing to note, if you haven't studied physics yet, these two terms sound exactly the same, velocity and speed, but they're kind of different. Velocity is speed. Velocity is the same thing as speed, but with a direction. So velocity could be like positive 5 miles per hour, negative 10 miles per hour. Okay, it has a direction. Okay, speed is the same thing, but it's only positive. Okay, so speed can never be negative. Or if you see in this formula, speed is just the absolute value of velocity. Okay, so here's an example. We'll go over more of these in class, but I want to go over an example of these types of problems where calculus and physics are kind of in the same problem. So say, for example, use a position function, this, for an object moving vertically near the Earth's surface, where s is measured in feet and t is in seconds. v0 is the initial velocity. Here's v0. s0 is the initial height. So let's look at the example. A baseball is thrown vertically upward with initial velocity of 46 feet per second. Okay, baseball, a guy's throwing it, and the guy is 6 feet tall. Okay, and let's assume that the player releases the ball at his height. Find the position, velocity, and accelerations for the baseball. So some of you are saying like, okay, word problem, I have no idea what to do. Okay, but don't worry, you got this. Okay, here's my position function. I can't take its derivative or do anything with it because I have this v0 and I have this s0. But luckily the problem told us what they are. My v0, it says my initial velocity is 46 feet. My S0, my initial position, remember the guy is 6 feet tall. Okay, so all I'm going to do to find my position function is just plug those in. Okay, so my position function, I'll call it P of t. Okay, I know the notes say S of t, but I'll say P is negative 16t squared. Okay, again, I'm just following this formula right here. Velocity is 46, so I'll do plus 46t. And then S0 is 6. There's my position formula. Okay, very simple. Next, the question says, what's the velocity function? So to take the velocity, I need to take the derivative of position. So velocity, if I take my derivative, will be negative 32 t, okay, because it's negative 16 times 2, plus 46. That's my velocity function. And the last thing is acceleration. Again, acceleration is the derivative of velocity. So acceleration is going to be negative 32. And there are all three of my functions. Okay. Next, the question asks, and this is where people get confused, is what's the height, velocity, speed, and acceleration at time equals 2 seconds? Okay. So they're basically saying when time equals 2, find all four of these. Okay. So let's start with the position. Where is the baseball at 2 seconds? Well, let's go to the position and plug in 2. 2 times 2 is 4, or 2 squared is 4, times negative 16 is negative 64. 46 times 2 is 92, plus 6. Okay. And then when I solve this out, I get 92 minus 64 is 28. 28 plus 6 is 34. With all these problems, with any word problems, you should always have units. It says, where's the height? Height is, in this particular case, feet. So the answer is 34 feet. Okay. Now, I need to find its velocity. Same thing. I'll plug in 2 here. Okay. So velocity at 2 seconds equals negative 32 times 2 plus 46. In this case, negative 32 times 2 is negative 64. Negative 64 plus 46 is negative 18. And again, I'm going to need units. For velocity, the units are feet per second, or units length over time. Okay. Next, the question says, what's the speed? Remember I told you velocity and speed are exactly the same thing, except for speed can never be negative. So the speed at 2 seconds is 18 feet per second. Okay. All you do is take the absolute value of velocity. And the last one, acceleration. You notice in acceleration there's no t here. There's nowhere to plug in to. This tells me that the acceleration everywhere is always negative 32. And the units for this case are units of length squared over... Oh, wait. Feet per second squared. So it's units of length over time squared. Okay. Now, that's how you do these type of problems. Okay. C says, what's the average velocity of the baseball over the first 2 seconds? So some of you may have forgot how to do average. Okay, I want to do the average velocity. So what I'm going to do is I'm going to take the velocity at 2, take the velocity of 0, and average it out. It's like divide by 2. Okay. I already know that the velocity at 2 seconds is negative 18. Okay. Let's find out what the velocity is at 0. Okay. So velocity at 0. If I plug in 0, I get negative 32 times 0 plus 46, which is 14 feet per second. Okay, so here's the velocity at 0. Here's the velocity at 2. If I want the average, I add the 2 and divide by 2. Okay, so average this out. If I add these two, I get negative 4. And divide by 2, I get negative 2. So my answer is negative 2 feet per second. And the last one for this particular problem says, what is the velocity of the baseball the instant before it hits the ground? Okay. So somebody's saying like, I don't get this one. What is the velocity of the baseball the instant before it hits the ground? I'm going to have to do two things here. First of all, in all these problems, I can't do anything unless I know the time. Okay. So I need to know what time does this hit the ground. Okay. So I'm going to look at my position function. Here's my position function. And I'm going to set this equal to 0 because that's when it hits the ground. So I'll take this position function, negative 16t squared, okay, plus 46t plus 6 equals 0. And the whole point of this is I'm trying to find out what t is. I'm trying to find out what time does this hit the ground. I told y'all you could solve this manually, like you could do factoring, but for calculus, again, your point is to try to get this as finished as soon as possible. So I'm going to use, as I mentioned to some of you, I'm going to use a quadratic solver and by doing so, I can solve for the answer without having to solve this out. This app is called Quadratic Formula Solver, or you can just Google one and you'll find it also. In this quadratic formula solver, all I have to do is plug in A, B, and C, and it'll tell me what the answer is. So the first one was -16. The second one was 46. B is 46, and C is 6. So let me go back. 46 and 6. So it tells me my answer is -1.125 and 3. Okay, so let me show you what that means. That means this whole thing can be factored into t minus 3 and t plus 0.125, because that's what oops, sorry. Oh, not restarted. Okay, I'm back. So it tells me the answers are either either t is -1.25 or t is 3. Okay, or if I go back to my problem, oops. If I go back to my problem, that tells me the answer can either be, wait for this to load. Just give me a second here. So it either means that the answer is -1.25 or 3. And one of these answers is not going to make sense. Okay, so again, based on my formula app, these are my possible answers. Either t equals -1.25 or t equals 3. Okay, y'all are bright enough, you're an AP Calculus PC, that one of these answers doesn't make sense. Okay, this answer doesn't make sense because I can't measure how fast the baseball is in negative time. I can't go backwards in time. So this is the only answer that actually works. The ball hits the ground at 3 seconds. Let me put the units there, at 3 seconds. Okay, but the question doesn't ask me when does it hit the ground. It says what's the velocity when it hits the ground. So first I found the time when it hits the ground, and I will take this and plug it into my velocity formula. So velocity of 3 is -32 times 3 plus 46. -32 times 3 is -96 plus 46, which is -50. So this tells me, and again I'm going to put my units, this tells me that at time 3 seconds, the ball has hit the ground and its velocity is -50 feet per second. Okay, so that is how you do these types of problems. We'll do a little bit more examples in class, but I just want you to get a feel for how to solve these problems, especially since you've seen so many last year. If you have any questions, you can feel free to message me. You're going to add it to the quiz, or you can see me in class. And that's all for this lecture. Take care and have a good day.